Good morning, everyone. On behalf of Vellalar College of Engineering and Technology, I'm very happy to welcome you all for the second day of AICT sponsored STTP Series 2 on Deep Learning Applications and its Challenges in Big Data. The topics that will be covered in today's session are hands-on training on deep neural networks, hands-on training on artificial intelligence with deep learning, Hadoop architecture, HDFS and MapReduce, big data tools. I would like to express my gratitude to our respected speakers who have accepted the invitation to preside over this STTP. Now I request Ms. S. Kriba ma'am to introduce Mr. Jay Ganesh sir, guest speaker of session 1.
Good morning. It's my pleasure to introduce Mr. Jay Ganesh Suresh, who is going to train on the topic deep neural networks. Let's see a quick intro about our speaker. Mr. Jay Ganesh Suresh is currently working as Senior Lead Engineer at HCL Technologies in Engineering Research and Development. He is also a speaker of Indian Book of Record holder for conducting most number of people involved in AI workshop. He has 6.5 years of experience in training domains as freelance, associated with many MNCs and education institutes. Over the years, he has been a part of many faculty development training programs, presented guest lectures, and also conducted 100 plus workshops in various reputed colleges and many educational institutes with various technologies around India. His area of specialization are artificial intelligence, machine learning, deep learning, robotics, IoT, and many more. So now I will hand over the session to Mr. Ganesh.
So, okay. So, I hope that my presentation is visible to everyone. Okay, now, yes. Okay, 1 minute. Okay, so I hope that my presentation is visible to everyone. Okay, now, yes. 1 minute. So, hello everyone. I hope I'm audible to everyone. Sorry for the interruption. Okay. So 1 minute. Okay. So, hi everyone. I welcome you all to this deep neural networks workshop, and I would like to respect to the sirs and madams and whoever present here to listen the session which is taken by me, and you all have got enough introduction about me. Anyway, I'll take a moment to introduce myself in a tiny manner. Though this is Jay Ganesh, who is working in HCL Technologies as a senior lead engineer. So that my complete working domain is based on artificial intelligence, machine learning, and the deep learning. So before get indulged into this event, I would like to know, I hope you all are really safe in this quarantine day, and hope that you all are doing good on this quarantine day. Okay, because nowadays we all wrapped into the work from home structures, right? So that it is really bang in many situation, and it be what is it, blossom for many uh, possibility situations. Okay, so in the yesterday's session, you all have seen about what is a deep learning and how neural networks is been working on. I mean, the techniques you have seen in the last session, I guess, which is taken by Deep and Raj. And today, so what's special? So almost the neural network concepts coming here, right? And what's special we're gonna see it here. So one thing here is we're going to see it's a complete based on hands-on. And more than that, I would like to take 10 to 15 minutes of your time to get recap of what is neural networks and what are the techniques we are using in a neural network. So because when I explain into the script, it would be useful for you all to understand the concepts, because if I give the recap, that would be useful for you to understand in a better manner. So that is what I'm just taking a recap. And what is artificial neural network? You all knows it, right? You all knows it. So neural network is nothing but it is a same structure which our brain has. Okay, each and every neuron will be connected to the another neuron in order to transform the informations. One neuron doesn't possess any valid information that will not be connected to any other neuron, or that means it will not transfer the inputs to the another neuron. So the same way artificial neural networks we have prepared as a structure. So this is how we have classified into the input layer and the hidden layers and the output layer. So this is what we have classified. Okay, so how the neuron will be, so how single neuron is doing an operation, we given a set of inputs. Okay, and that inputs will be active, will do process, and it will get activated, and then it will be transformed as an output. So between input and output, you could have noticed are two factors. One is a weight and another one is an activation function. I'll tell you about what is a weight. Weight is nothing but whenever you are transforming an input, if you give that value directly to the what is that the neuron, that will not be useful, because you could have seen at the final output in a linear relationship between an input and output. So in order to do that, we are using an activation function in each and every neurons. And weights is called an uniform distributions, or what is it, distributed. So different distributions, uniform and a randomness distribution, we could have used in order to change the input values to the neurons. So this is what, so how we going to connect a single neuron into the factors of multiple neurons. So this is a way. Okay, this is a network we have with the multiple neurons as classified as the input layer, hidden layers, and finally output layers. Okay, how it works, a simple, we have given an input. Okay, all the inputs, for example, I have taken an image here. Okay, each and every pixel will be transformed to each and every neurons, and then each and every neuron will not directly transform those values to the hidden layers. Okay, so that formula you could have observed in upper layer, right? Summation I equal to 1 to n wx plus b. Okay, so w in the sense it's a weight, and x in the sense input. Okay, w weight into input plus biased. Okay, so by clubbing together, that value will go to the hidden layer. So when that hidden layer 1 will be connected to the hidden layer 2, there we will consider the concept called an activation function. Okay, I will tell you everything in detail. Okay, so now just a minute, it, it drops me some. Yes, yeah, coming back. So now if you observe this, Activation function. What is an activation function? Because generally we used to say a neuron will be used to activate, okay, if it has any worth information. So generally we used to say this is an activation function, but technically the answer is activation function will help us to generate a non-linear relationship between an input and output. For example, if you want linear relationship, we can directly use a linear regression in a machine learning algorithms, but we are using a neural network. So if you are using a neural network, there should be linear relation, that should not be a linear relationship between an input and output. That input which we have got should undergone with a multiple process in order to understand the possibilities of an output. For that purpose, we are using an activation function. So what is an activation function? What are the methods we are using? So yesterday you could have get an enough idea about what is an activation function. So what is the threshold, sigmod, and everything. So I'll go a little simple. Okay, the first one, maximum we could have used is a relo. Okay, rectified linear unit. So why we are using a rectified linear unit more specifically here? Any idea about it? The reason behind of is nothing but because relu will not consider the negative values, it will consider only the positive values. If the value anything below zero or the negative, it will not consider those values. Okay, and more than that, what are the transforming the what are the value transmission has been happening, that will be considered as it is. Okay, so we could have understand the what is the worth of a neuron values. And in some cases, not in a some cases, whenever you are working on binary classifications, okay, binary classification in the sense yes or no. So in this kind of scenarios, in the output layer we will be using another activation function called sigmoid function. The sigmoid function will be useful to understand that whether what is that whether it is a flower or not, whether it is a dog or not. In this kind of scenarios we will be using a sigmoid function because it classifies between the value called zeros and ones. So, and I hope it's clear, relu is nothing but in order to create the non-linear relationship, non-linear in the sense in order to prepare the in order to what is a reduce the negative values, and more than that it will prepare some non-linear between a what is that one neuron to another neuron. For that purpose we are using a relu. And when we go for the binary classification, at that moment we can go for sigmoid function. So when I explain throughout script at that moment, it would be really understandable way for you all. Okay, and so this is what I said, rectified linear unit. If you see the picture, if you closely observe the pictures, black factors in the input feature map is right, everything black, everything is being considered as a negative, and white, everything is being considered as a positive. Okay, now I applying the relu activation function upon this picture. Now if you see the rectified feature map, you could have understand what exactly I'm coming to explain. Okay, it reduces a negative value. So because all the values which is going in the black will possess some negative values, so those negative values has been reduced up there, and it will consider only the positive values. And you could have think about the next level. So what if the negative values possess some information? So okay, I'll be giving you the details in the script when you come for. Okay, and so how this math behind of an activation function? Very simple, very simple. So this is what, okay, so first I have an input layer, I mean the input neuron 2. Okay, so now I'm using here normal distribution. Just consider as a here I'm using initialization as a normal distribution. So 2 into 0.5, which is equal to 1. Now the it is a hidden layer, so it must have some activation function. That activation function here I referred as a sigmoid function. So sigmoid function, now it will be multiplied as a 1 into zero point 0.7. So that is a value of that a hidden neuron. So zero point 0.7. Now again I'm applying the what is the normal distributions. Okay, so the weight is being generated as a 0.75. Now I'm doing the same operation here, is that summation I equal to 1 to n wx plus b. Okay, and that formula I am applying here, zero point 0.7 into 0.75, which is equal to zero point 4. Okay, so after applying this value with a sigmoid, my prediction will be 0.6. Okay, now what is a bias? So we have discussed about w x plus b, is that right? So what is the purpose of b? In order to made it bias of your model, okay, because which in every time, so here we have simply classified with the three neurons and only one hidden layer. But when you go for the real time, at that moment you could have used multiple hidden layers called 5 layers, 6 layers. Sometime the necessity would go for 128 or 512. Likewise, the hidden layers will go on, and the neurons also we will be using in terms of 128, 512 and 64. Likewise we'll go for. So at that moment the communication between one neuron to another neuron values, it's a typically hard. At that moment, obviously, if you are not biasing your model, the output value may get some unprediction values or may give some, what is that, non-valid values. In order to avoid that, we keeping some bias values to make your neural network model to be biased. So for that purpose, if you see the if you see the model, the picture 3 into 2 general w into what is that, x equal to 6 plus b. That b here I have mentioned as a biased, so 1 equal to 7. So now I'm putting that value into the sigmoid and I'm getting as a value called 0.99. And the same value, the same process which is occurred on the next layer, I mean the output layer, also I'm applying the same. Okay, I hope you have get some idea about what is a biased and what is a weights and what is an activation function. So okay, because activation function, if you see the input 3 and if you see the output 0.99, okay, obviously there is no relation between the input and the hidden layer. And if you closely observe the final output, there is no complete relationship between the input and the output layer. So some other randomized value it is giving, but the prediction will be more accurate. Okay, and what is a back propagation? So how this kind of, okay, how this kind of value biasing, so I mean how this kind of prediction value is been getting. Okay, so how we are getting a proper prediction values? So one during the one iteration, I mean the one for one propagation, I mean one forward propagation, so we will be getting the proper actual prediction value. That is not a true, because with the help of a single forward propagation we can't get the exact prediction what actually we are expecting. So to do it we have another option called a back propagation. Back propagation, it is a kind of a process updating the weights to the network in order to reduce the error in prediction. So confused, don't get confused. The first time I'm doing the forward propagation, I'm getting some actual values, I'm getting some prediction values. So since I know the actual values, I'm applying a loss function up there. I will tell you what is a loss function. And applying a loss function up there, and that is giving you that is giving me some magnitude of responses. That magnitude of responses, for example, if you see a, okay, the magnitude of what is that slope, the magnitude of slope is upper. Okay, if you go for b, the magnitude is getting low. And by adjusting this, by understanding these values, so I'm saying that okay, however my value, so my error rate is higher, however my error rate is higher, so I have to approach another propagation, I mean, so I need to reverse back the back propagation, I need to approach a back propagation. So again I'm tuning the weights, from the hidden, from the input layer to the final output layer. So again it will be giving a set of predictions. So again I'm applying a loss function and I'm calculating the error rate, and I'm understanding the magnitude, whether the slope is more higher or very less. Okay, until unless I'm meeting the very less number of very less loss function or else equal loss function, I will not be stopping this process. Okay, so at least it's not a mandatory we should go for error rate as a zero point 0.0. So that is not, when you come for real time application, that's not pretty impossible, that is pretty impossible. But we can achieve point 0.1, we can achieve point 0.2 point, that is possible. So this is a way we have to do, this is a way we have to work on some hyper tunings. Okay, we need to define how many times back propagation and everything should happen. Okay, so the loss function, as I told you earlier, it is used to calculate how wrong our prediction model is. Okay, this will be useful to understand whether the first forward propagation, the forward propagation of a model will given a proper prediction or will given a proper what is that, will have a less error rate or not. So if it has a more error rate, just go for a back propagation again. Okay, again it will give. So likewise, the loss function will define the back propagation. So everything this kind of process and backpropagation, you are talking about a multiple things, like backpropagation you are saying, and the loss function you are saying, how everything is been organized with a single term. So that is we called gradient descendant. Okay, that is a optimizer. Okay, because that is an optimizer algorithm that we have a multiple optimizer algorithm called stochastic gradient descendant and mean stochastic gradient descendant, and we have many what is that, gradient descendant. So that is an algorithm, that is an optimizer, will correlate, will organize all the functions called the loss function and the back propagation. Okay, so this is why I said, just keep on it. And gradient descendant, so gradient descendant will give you less number, will calculate the what is that, the will do the many momentum, and it will find the minimum of a function. Okay, so if you closely observe this, what is that, in this graph, so I have plotted the values between a weight and the loss. Okay, so now I got a graph here. So now I'm calculating the less number of loss. So if you find it here, the when I update a weight called 6, I'm getting the loss function as 0. So that is pretty possible. So now what your model will do, in the sense your optimizer, what it will do, it will update the weights across the neural network model as a 6, and it will tune the values, and it will be giving you the predictions. No, that before that it will do the multiple iteration. Okay, weight equal to 3, weight equal to 6, weight equal to 9, weight equal to 12, many weight it will update, and finally it will accumulate everything, and it will plot in this kind of graphs, and it will understand the graph between a weight and a loss, and which weight has a less loss function, that weight will be updated across your neural network model, and finally it will be giving you the predictions. Okay, so this is a process which is happening behind the neural networks. Okay, and pretty things are many things are there, like so hyperparameter tuning. So before that, I'm just getting into the script, because so I have just taken this to understand you, like how this is actually work, how the neural network works, and what are the topics we are working behind of it. So to make it understand, I have just taken this now. Yes. So it is presenting my screen, entire screen, I guess. Yes. Okay, so now, so here I'm going to use a platform called Google Colab. So now I'm turning to the, what is that, the hands-on session. So far I have explained you what are the terms are present in our neural networks, the back propagation, and what is a loss function, and what is an activation function, and how these kind of stuffs are going to use when you develop a script. Okay, so that is what we're going to see. So in order to explain you the script, I'm going to use a platform called Google Colab. So we have a multiple Colab, we have multiple platforms, right? Jupyter. Likewise, here I'm just going to utilize Google Colab. So this Google Colab has been provided by the Google services in order to um, develop your machine learning and deep learning models. Okay, you would have, some people might know, some people may not know. So just get experienced of Google Colab. So here you could have think about it. Okay, in order to work on machine learning and deep learning stuff, so we should have known a lot of things. I mean, your machine should possess enough RAM, and it should have enough room, and more than that, it should have a GPU. Okay, so that is very important, right? Yes, exactly. If you think, if you confused of those areas, okay, if you're confused of those areas, here I'm just getting into the Google Colab. I'm just connecting my, what is that, my home server with the Google Colab server. Now just understand, I'm just explaining. Okay, now it is initializing. Now it is initializing, and now it is connected. My server, my home server is been connected with the Google Colab server. So Google Colab is a place where you can develop and deploy your deep learning models, right? Deep learning and machine learning models. Now see it here. So they are providing the RAM called 12 GB. Even our systems may have 8 GB, and some of them may have 16 GB or something else. And see, in this Google Colab, they are providing the RAM size called 12.72 GB. Okay, so far I have utilized only the 0.7 GB. Okay, see, because I'm not deploying any, I'm not preparing any. Okay, and the GB and the storage space they have provided here for 107 GB. Because why have they provided 107? In the sense, you could have used this Google Colab for images also, because whenever we are deploying CNN models, I mean, what is that? Convolution. When you work for convolution neural networks, when you go for some RNN, at that moment you could have get a chance to update. You could have chance to upload the image basis. So at that moment, we should have a minimum storage. However, this is a minimum storage only, but you can use this Google Colab, okay, with the help of this RAM and ROM to develop your models, and you can deploy your models. And you could have asked me another question, that how it is possible to deploy a bigger level of bigger models, like if I have a 1024 cross 768 images, it will require the GPUs, right? However, it requires a GPU since it's take a more number of process. Yes, for that query also, Google Column have provided what is that solution for it. Now, hardware declaration. So hardware accelerator, here I have used none, I'm not using any. Okay, so now you can use GPU. They are providing you services called GPU also and a TPU. I'm not pretty sure about TPU because we are not we won't deploy TPU. However, so GPU we are using here. You can just upgrade your hardware as a GPU and you can just save. And if you want to deploy any model with the high number of graphical or high number of processing time required, in the sense you can have change your runtime model into the GPU. Okay, this is a purpose Google Colab has been provided this platform, because for student initially students have been utilized this kind of platforms. Nowadays many staff members and as well as doctorate members also utilizing this Google Colab to develop their models or something else. Okay, just get into it and just utilize this Google Colab. So now I'm going to use this Google Colab to explain the hands-on session. So now I'm getting into my GitHub model. So here, this is my profile, GitHub Jayish19. Okay. So in here, then artificial intelligence, the deep learning concepts. Okay, so here I have a multiple scripts, and I will tell you what are the things we're gonna see today. Okay, so we're going to see multi-layer perceptron related concepts. So multi-layer perceptrons, it's a neural network concepts. So multi-layer perceptrons, we'll be having a multiple layers, not in a single layer. It is because we can use sometimes linear regression also, linear regression model also we could have saved as a what is a perceptron. But here I'm going to use a multiple layers. That's what we call it as a multiple layer perceptron. Okay, so in this multi-layer perceptron, we're going to see a binary classification. Okay, a person is having a diabetes or not. Okay, so this kind of binary classification, and the next one is multi-class classification. Okay, binary classification is pretty simple. However, you all get and understand, like, okay, we're going to understand whether the person is there or not. So it is, we can use for logistic regression also we can use. So if you think this is a simple, next we can go for multi-class what is that neural network. So that multi-class will be giving, you will be having a multiple classes called 0 1 2. So we're going to classify which model, which kind of output type this is. So binary class and a multiple class at the end of a session, if I got a real time, okay, if I got enough time, and I will be explain you, okay, the real time product called the real time project of one real example I have. So that also I will be showing you. So far I'm going to show you how we're going to develop a script, how we can utilize the script into the binary classification and the multi-class classification. So more than that, we're going to use the same script, and we're going to tweak a little bit into the same script to be utilized into the real-time products. Okay, so this is a agenda we're gonna see today. So first just give an observation up here. I'm just going to file, open notebook. I repeat once again. Okay, file, open notebook, here GitHub, because I'm going to deploy the programs from GitHub profile. Not because if you want to utilize in your Google Drive, you could have do. And if you have any local what is that projects with the extension called .pynb, so you can use reason. If you have any local examples in the Google Colab itself, you can deploy it. Okay, and if you want to upload any programs which is present in your my computer or something else, you can upload and you can deploy. So here I'm going to use a GitHub repository to deploy the sample models. So Jayish, this is my GitHub name, Jayish19. Just give an enter, and in the Jayish 19, there'll be a multiple branches: machine learning, deep learning, Python, hands-on coding, and complete tutorials. And here I'm just getting into Jaish 19 artificial intelligence. Okay, in this folder I have a multiple scripts. In this multiple scripts, okay, so now I'm going to show you multiple layer perceptron. Okay, multiple layer perceptron neural networks. Okay, so in this multiple layer perceptron, I'll be having a two type of scripts. One is iris multi-class classification, and another one is pima binary classification. Okay, so these are the two examples initially we're going to explore. Okay, so first I'm going to explore pima binary classification. Okay, I'm just taking the so now here I'm just searching for my Pima binary classification. Yes, under multi-layer perceptron folder, here I have Pima binary classification .ipynb. This is an extension I have told you earlier, because if you want to deploy a model or script into your Google Colab, you're supposed to have that extension called ipynb. So now I'm deploying this model and it is asking me to leave. Yes, now it is deploying. Yes, so here I deployed my model. So before that I'm ensuring that whether my what server is connected with the Google server. Yes, it is connected. So now I can directly deploy my program. So before that I will be explaining you the I will show you the layout of the scripts and a simple MLP for Pima Indian dataset. Okay, these are the attributes are present in the dataset, and I'll explain you the dataset how it actually works. And this is a script flows. Okay, the git clone is nothing but I'm just cloning my entire repository to Google Colab in order to use the what is that the data set which I have in the repository. Okay, so for that I'm using git clone http github from the profile. So just keep it out for my reference. I have added this. So I'm just in what is it cloning my entire repository to Google Colab in order to upload what is that the data sets from my repository. Okay, and more than that, importing packages, loading the data sets and splitting input output, creating the model, compiling, fit and evaluate. This is about the scripts. Okay, so now first I'll explain you the dataset. Simple MLP for Pima Indian dataset. What is the meaning of Pima Indian dataset? It is a universal dataset for any developer can use to develop your script or tune your script or to understand better your script. You can use this kind of home or else what is that universal data sets for your development. And here we have a multiple inputs that call pregnancy numbers of time, how many times of pregnancy happened, glucose plasma and blood pressure and skin thickness, insulin, BMI, body mass index, diabetes level, age, and finally the outcome. Okay, so almost here I have a 8 parameters. I mean, I have 8 attributes as an inputs and 1 attributes as an output. That 1 attribute references has a 0 or 1. Okay, by consolidating all these values, it refers a person is having a diabetes or not. This is what we're going to classify upon here. So if you wants to have a look on data set, I'm just showing it here. Okay, here. So this is my data set. So see, so these are the 8 attributes: pregnancy and glucose and BMI mass body and diabetes before, and along with the age. These are the 8 attributes. By consolidating these 8 attributes, this fellow has a diabetes. Okay, now I have another set of attributes. This fellow has a no diabetes with the having this kind of what is that attributes. Now likewise I have almost 768 entries in this particular data set. So almost 760 entries are there. So it is not a bad data set, but pretty good. Not much, but it is a pretty good. Okay, so this is a data set I'm going to use in my local model to understand the neural network concepts. Okay, so I hope you're very clear with the data set. So this is a Pima Indian data set. It will be having 8 attributes. That 8 attributes will tell you whether a person is having a diabetes or not. Okay, the attributes are represents are here: pregnancy numbers, glucose plasma, BMI, body mass and insulin and age and everything. Okay, all 8 factors are consolidated and finally outcome as a zeros and ones. Okay, now we can get into the scripts. Okay, so now I'm cloning my model. So if I, in order to explain this line, you just observe it here. Okay, so 1 minute. What I do in the sense, I'm just deleting this folder. Only empty. Okay, fine. Then it is not a worry. Okay. Okay, so now when I just running this particular line, when I'm just cloning this particular line here, you can then only this artificial intelligence repository completely will be cloned here. The reason for cloning the complete repository from my GitHub, because here I'm importing the packages. Sorry, here I'm importing my, what is that? Um, data set, Pima Indian data set. So in order to download this data set, from my repository, I need to clone it in my Google Colab. That is the reason I'm just cloning it here. So through this it'll reference. So you could have think about it like, what if this artificial intelligence repository not cloned here? So at that moment when I running this particular line, it will giving me the error, because it will say the data set is not present in the Google Colab home repositories. So that is what I'm doing, this kind of cloning, because when whatever script I'm explaining it during this session, everything will be having this clone line, because I need to clone my repository here, because all the data sets are there within this repository. So through this repository I'm just downloading and just referring the data set to here. So that is a purpose I'm using this cloning operation is here. Okay, so now, so it is listing out what are the parameters, so what are the folders are present in the clone, what that repository, it will list it out, just keep it out here. Now we can get into the concept importing packages. So what are the packages are primarily required to deploy this model? Okay, from keras dot model import sequential. Okay, so here I'm using a platform called keras. Okay, from the keras, the models, many models are there. From the model I'm taking a sequential. Okay, the reason for I'm taking a sequential, because I'm going to deploy the model in terms of the sequential order, because my neural network model input layer, hidden layers, output layer, so it is a kind of a some sequential connection. So that is the model name called sequential. So in that API, okay, this sequential we called as a API. For example, keras is like your computer, I mean your laptop, Dell or something else. Okay, from laptop dot os import Windows. So that API. Okay, so in Windows only you are doing all kind of operations, right? The same thing. Okay, so from keras, okay, I'm just importing the models. So from the models I'm taking a sequential API. This API will allow me to prepare my model, to construct my neural network structure. So I'm using this API to develop my neural network structure. And the next one is from keras dot layers import dense, because we will not construct neural network model with the one neurons or two neurons. However, it will be having a multiple neurons, and however it will be having a multiple layers. In order to construct that one, we need to use the from layer, from keras dot layers import dense. Why we are saying it as a dense? In the sense, because the neural network model looks like a dense model, because multiple neurons will be there, multiple layers will be there, so the complete model itself will look like a dense model. So that's what the layer named called dense. Okay, so I'm just importing this dense. Through this dense I can deploy many neurons for the single hidden layer or input layer or something. Okay, the next one is import numpy. Numpy is a classic tool which is using across all the ways, CV neural network or machine learning, whatever it is, we just using the numpy for numerical processing. Okay, so now here I'm just doing on another operation called seed equal to 7 and numpy dot random dot seed of 6. So the reason for these two lines is nothing but to prepare the non to prepare the randomness between a model. So why am I saying in the sense, for example, read seed equal to 7 I have given, right? So if I train my model, if I let my model to train, in the sense it will start learning from one by one, 1 2 3 4 5 6, likewise up to 768 lines will be learned in this order. So if it's learning line by line, in the sense there will be a chances of linear relationship between this one what is that one cell to one another cell, because so first one in the sense, the second one zero, so second third one in the sense, the fourth one zero. Likewise your model might be memorized. Okay, maybe it get memorized in this order. So in order to avoid it, we are preparing a randomness on our model. So what kind of randomness we are doing? So that is what seed equal to 7 I have given, just to do the randomness. First 7 lines it will take. Okay, the next 7 lines might be somewhere else. So the next 7 lines might be somewhere else from here to there. So now if you look on the output, or if you look on the each and every cell, there will not be linear relationship between a one cell with another cell, one set of inputs with another set of inputs. So it will prepare some non-random, so it prepares some non-linear shift. So this is a matters. For that purpose, we are using a seed concept. Okay. So now, so where are you going to use this argument? Yes, coming the concept. Load Pima Indian data set. So data set equal to numpy dot load text. So this is from this folder. From this folder, I'm just importing my package Pima Indian diabetes dot csv, and giving the delimiters called comma. So why have given delimiters? In the sense, it is a reference for my model to understand each and every cell. Okay, each and every value is being, what is that, separated by the cells. So in order to understand that, it will be we giving the delimiter as a comma. So that means it will understand 6, 148 and 72, 35, everything has an individual value. If you're not given in the sense, it will get confused and it will be understanding in some other manner. Okay, in order to understand each and every cell is separated, if you want your model to understand with the cell by cell, you have to give the delimiters called comma. Okay, now my loading the data set is done. So for importing the order, importing the packages is done, and the seed is done. And the next one is loading the data set is also done. Next to what? Okay, next to what? Okay, splitting into input and output. Okay, so the first one, x equal to data set of colon, okay, comma 0 colon 8. So I'll explain this one. So now my data set refers the object of my data set. Okay, that object of my data set. So from here, the first one always, this first place always refers the rows, and the second value always refers the columns. Now here I'm saying I'm not giving any specific rows. From this row you have to start, from this row you have to begin your counts or something else. I'm just giving just a column. Okay, from the first column, from the zeroth column you start pick. Likewise I'm saying, and the next one is from 0 to 8. Okay, from 0 to 8 you have to take as an input. That means, so first row, I mean the first initial row, just a given column, right? So from the 0th row itself, you can take pick as a input, and the next one 0 to 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Obviously, as per the Python, it will not consider the eighth value, so it will consider 0 to 7. If I give 0 to 8 in the sense, it will consider 0 to 7. So these are the values are considered as an input that will be stored in a x. I'm repeating once again. I'm taking this dataset object, and from the object I'm saying there is no row specification. Start from the initial row itself, and the column specification 0 to 8. 0 to 8 in the sense, from this column to this column it will come. Okay, so likewise it will be applicable for all the 768 lines. Okay, so all the 768 lines, 0 to 7th column is been captured as a input, and the output I have referred here as a y equal to data set of column comma 8. So the eighth column, that eighth column refers is always this column. Okay, 10100, this is my eighth column, so I'm taking that as my final column as an output. Here I'm saying the same, the row specific is not there. You just start from the first row itself, I mean the 0th row itself. You start and take all the values of the 768 entries. So this is what I'm just splitting my input and output. So now my splitting input and output is done. Next, what it is, so the creating a model. Okay, as I told you earlier, the API. So in this sequential API, I'm going to construct my neural network model. So this API name is called sequential. Okay, sequential model equal to sequential. The object, in terms of object, I'm storing it here. Model dot add dense of 12, input dimension 8, inter is uniform, and activation. I will tell you what it is. Okay, so now I have deployed the model. Okay, now I have deployed the API as a model. Now in that model I'm adding the layers. I need to construct the neural layers, right? So for that, first layer is a dense layer. As I told you earlier, whenever you wants to add a layers of neural networks, you have to use a dense. Okay, I'm adding the dense layer. How many neurons? 12 neurons. Okay, so first neuron is a 12 neurons. Okay, and the input dimension is a 8, and in it is a uniform, I mean a uniform distribution. It is not a mandatory to what is that, to be given here. And the activation function is a ReLU activation function. That means rectify linear unit. Okay, so next one, model dot add dense of 8, and the next activation function is a ReLU activation function. So finally the output layer, this is the output layer, because since it is a binary classification, we can just take a one neuron up there, 0 or 1. For that purpose I'm taking only one neuron here. If you observe the activation function referred as a sigmoid. So what is a sigma? Why we have using the sigmoid? Since it is a binary class classification. For that purpose I'm using, because if I use ReLU here, in the sense it will be giving some, what is that, it will be giving some discrete related values. That discrete values will not be useful to understand your model to classify whether it is, the person is having a sigmoid, what is that, is having a, what is that, diabetes or not. So for that purpose I'm using an activation function called sigmoid activation function. Okay, so here, so I'm just explain you how actually it works. One minute, I'm just taking a paint here. Okay, first one, dense layer 12, right? First dense layer is a 12 and the input dimension is a 8. Because why is the input dimension is 8? In the sense, because totally we have a 8 set of inputs. So that is what each and every value will be going for the each and every neuron. So the purpose I'm giving the input dimension as a 6. Okay, so your model will be like 8 input neurons. Okay, 8 input neurons, and the next one is model dot add dense layer of 12. Okay, model dot add 12 in the sense, so 12 hidden layers, 12 hidden layers, 12 neurons of hidden layer 1, 12 neurons of hidden layer 1, and the next one is 8. So next layer, hidden layer, is a 8 neurons of hidden layer 2. So the final hidden layer is 1. So final hidden layer output is a 1. Okay, so I hope it's clear up to this. Now next one. Okay, so activation function, the matter is coming here for the activation function. Okay, so here I'm using an activation function called ReLU. Okay, when from here to there the value will be transformed in count of ReLU. So from hidden layer, from 8, okay, for the 8 and the 12 between, so here also I'm using ReLU activation function. So when you go for model dot add dense layer of 1, so that means here output layer, here I'm using a activation function called sigmoid. So here the activation function we are using is a sigmoid. Is it clear up to this? I hope it's clear up to this. So now I'm created the model, so my model is completely ready. Now I need to compile my model by seeing what kind of loss function you're going to use and what kind of optimizer, I mean the gradient descent and algorithm you're going to use. Those many things I have to report here. So compiling my model, model dot compile loss function I'm reporting as a binary cross entropy. Okay, so loss function I'm reporting it as a binary cross entropy, because since it is a binary classification I'm using a binary cross entropy. If it is a multi-class, you can use for categorical cross entropy. I'll tell you in the next script. Okay, so binary cross entropy, and optimizer is Adam optimizer. Okay, we have a multiple optimizer like Adam and Adagitcock, like we have a multiple optimizers. So here I'm just specifically using as a Adam optimizer. And the metrics, so what kind of metric, you can take multiple metrics like accuracy and mean square error, or likewise mean square error, many attributes are there. So in order specifically, more specifically here I'm going to show you the accuracy of a model. For that purpose I'm taking only one metrics to be considered as a accuracy. You can take any metrics. Okay, if you wants to know something sigma related metrics, you can take it off. And if you wants to know the, what is that, relationship between one neuron to another neuron relationship, that kind of metrics also you can take. And mean square error you can take, anything you can take. But here are specifically accuracy related, so I'm taking an accuracy metrics as 0. Okay, so the next one is I'm fitting my model. Okay, now my model is ready, deployed. My model is deployed, and here I deploy and have told what kind of loss function I'm going to use, what is the algorithm, I mean the optimizer algorithm I'm going to use, and finally I'm going to fit the model. So fit the model in the sense I need to give, I'm going to train my model with my input and outputs. So my inputs and output is always is like a x and y. So I'm giving model dot fit x comma y nb epochs equal to 200, batch size is a 10. Okay, so here the concept comes. Okay, xy. Okay, input and output is given. So now a model is ready to get trained. How many times you wants to get it trained, how many times you wants to go for iteration? 200 times I wants to take the iteration. So 200 times in the sense, overall my data set entries is around like 768 entries are there. Okay, each and every iteration, all the 768 entries will go around. Okay, so each and every iteration, all the 760 entries will go around. That many times the back propagation will happen, that many times the weights will be tuned in your neural network model. Okay, so that many times, that means 200 times, in the sense 200 times the back propagation will happen. 200 times, what is that, the weight updations will happen. If you think that only 200 times of weight updation will happen, that is not exactly. Okay, so on another concept comes here as a batch size, 10. Okay, what is some batch size? For example I'm taking, so overall you have a 100 data set. Okay, so overall you have a 100 data set. Okay, and you are giving the batch size as a 10, and you are giving the batch size as a 10. Okay, and you are giving the iteration called 2 iterations. Okay, so now overall 100 data set, and overall iteration, so batch size is a 10, and iteration is what, the 2. So during the first iteration, every iteration, during the first iteration itself, all the 100 data points should go around. That many times the back propagation should happen. This is our concepts, right? Okay, so here I'm taking a first iteration. Okay, so in I have given as a batch size as a 10. Okay, so first 10 out of 100, I'm taking the 10 randomized images or randomized data points. Okay, that first time, one what is that, sorry, back propagation will happen. That many times the what is that, the weight tuning will happen. The next iteration, okay, the not a next iteration, during the first iteration itself, first batches is a 10, the next batch is another 10. That means out of 100 and another 10 is been picked. So second time the weight updation is happening. Okay, so next batch size is a 10. So likewise it will go for how many times, 10 times it will go for, because I have 100 data points, I have given a 10 batch size. So almost during the first iteration, 10 times. Okay, 10 times this back propagation will happen during the first iteration itself. 10 times back propagation will happen along with the weight updation. So how many times during the first iteration itself, 10 times the weight updation is happened. Think about it, second I have given totally second iteration. So during the second iteration, the same operation will go under again. So at that moment it will go for another 10 iteration, 10 back propagation, I mean 10 times of value updation will happen. So just two iteration itself, it has done weight updation around 20 times. Okay, just two iteration with the batches of 100, so with the batches of 10, it has taken a back propagation, it has updated the weight across the model is 20 times. Think about this one. Okay, here I have given 200 times of iteration. Okay, 200 times of iteration. During the first iteration, okay, during the first iteration, think about it, the overall data points is 768. The batch size I have just given as a 10. Think about it. Okay, almost 70 time first iteration itself, 70 times the back propagation will happen, 70 times the weight updations will happen. So if your model is being deployed with this kind of complexity, obviously that will be giving you the proper predictions and exact prediction what actually you're expecting. But it is not a mandatory, because we are having another kind of issues, right? You could have known that, I guess, underfitting and overfitting issues. Okay, we will be for maximum will not fall. But if you are taking 100 epochs, 200 epochs I have taken here, if I take 500 epochs, obviously I'll go under some underfitting or overfitting issues. I will telling you that what is underfitting and overfitting issues. Okay, now, so now my model has been x and y inputs, so 200 times of iteration. So 200 times of iteration, so all the 200 times 768 data points should go for each and every iteration. Okay, so likewise 200 time, and the batch size is at 10. Okay, the next one is I'm just evaluating the score. I'm just evaluating the score using the model dot evaluate using the input of x y, and it will be giving you the scores, and I'm just printing the scores here. Okay, so now I'm just deploying this model, and I want, before that I repeat once again, I'm just importing the packages, I'm taking the data set, I'm just loading the data set, I'm just splitting the input and the output, and then I'm creating my neural network model here. Once I created my neural network model, I'm just start compiling it off using the loss function, and as well as using my optimizer. Okay, so now my model is completely ready to get trained. So for that, I'm giving the input and output, I'm just telling to my model how many times you just iterate yourself to learn something better. 200 times I reporting here, and batches of 10. Okay, and finally by doing this training, I will be telling you that how precise my model is. Okay, how precise my model to evaluate the output or something else. Okay, so now you can do multiple time of runs, like individual runs also you can do, line by line runs also you can do. Importing the packages, first I'm importing the packages. Okay, and randomize the seed. Here I'm just deploying the data set again, deploy the data set here. So next I'm splitting my input and output. I'm just creating the model. Oh gosh, I'm getting an error. What is an error? Keyword argument not understood initialization. Okay, so cause, what is the root cause? What is the root cause? Locally packages generic utilities, valid keyword arguments. Okay, might be updated, I guess. Okay, for keyword arguments. Okay, because this is a new Keras is updated, I guess. It is not a mandatory we should give this init uniform, because it is not a mandatory. You have all the times you have to give the initialization as a uniform distribution. You can just omit it off. Okay, by default it will be taking init as a generic. Now we can try. I hope it will not get error this time. Yes, correct. Yes, perfect. Working good. Okay, I've created the model. I just compile my model using the cross and trophies. Cross and trophy, and as well as optimizer. So compiling model is all done, and fitting the model. Again an issue. Oh my god. So meanwhile of this, a lot of updates have happened in a Keras, seems like. Okay, running inside run distribute coordinator already. So got an unexpected keyword. So okay, I think epoch. Yes, I'm just updating it here. So because a lot of update had happened in a epoch, what is that? Sorry, in a Keras, I guess. Meanwhile of this time. So see, I have given 200 epochs, right? See, epochs are running here 75, 84, 99, 1900, almost is getting run. So out of 200, we have almost reached 180. We are almost reached 180, and it is done. Just 1 minute. It is done. So all the 200 iteration is done now. So the matter you have to address here, the things you have to notice it here. Okay, okay, the little interesting things. Okay, so first iteration I'm going for here. uh, okay, the first iteration. Okay, out of 200, the first iteration, the loss function, if you observe here, 3.5. Okay, so loss here is a 35, I mean 35% is a loss, and as well as accuracy is a 44%. Okay, now we can just evaluate. Okay, 175. So okay, loss function has been bit increased a bit, or reduced a bit, reduced to 0.47. Earlier it was a 3.5. Now the loss function is a 47, I mean 0.47, when during the epoch of 175. So accuracy also is a better clear, right? 77, I mean during the first epoch, nothing it understands. So that moment the accuracy was a 44, and 175 fifth iteration, the epoch, it has understand much better. So I'm just understanding the another epochs. Okay, so now I'm directly going to the 200th iteration. Okay, here it's a bit more interesting. So loss function is a 4.4586. Yes, much clear and much better, and accuracy is 78%. Okay, 78%, it's good. Okay, so this is what, from the first iteration to the last iteration, if you started understanding each and every iteration laws and accuracy, you could have understand a lot of things. And you can see, you think about, in this epoch, you can ask me 80% is there. So now we can see the final output, what it says, because it will go for gradient descendant, and finally this gradient descendant will classifies, okay, which iteration is has a less number of loss function. Based on that, it is giving you the accuracy. Okay, if some other iteration out of 200 iteration, if some other iteration has a less number of very less loss function, that loss function will be picked up. So during that loss function, what are the weights were happened in that what is a neural network model, that weights will be updated. So at that moment, what accuracy we have achieved, that accuracy has been reported here. Okay, so now if you're not satisfied with this accuracy, you wants to tune your model with a better accuracy, even I myself wants to tune my model with a better accuracy, what we can do? Okay, we can do a many things, right? The first, what am I doing in the sense, 64, I'm just increasing the layers types, 32, and a little more interesting, I'm adding in another layer. Okay, yes, 16. And ReLU function itself, we can use some other, okay, it's a pretty factor. And this one, and binary cross multiply, we can't touch anything here. And epochs, we can try with this first. Okay, so I've just increased the layers, I have just increased the layers, and we'll see the accuracy and we can see the output. Accuracy has been improved or not? Oh my god, again it is taking an epochs. So iterations are on process. Yes, on process. Just excuse me, I have water. Yes, here we done. Now it's surprising, we'll see the output. It's pretty clear, right? So increasing a layer has given a accuracy as a 88. Now you could have asked me the question, so what if we undergone with the what is that, underfitting or overfitting? Maximum it is not possible, because we are starting with the basic models. We are not directly going to the 600th iteration or 1000 iteration. We are not directly deploying the dense layer as a 128 or something else. We are increasing our model little by little, we are tuning our hyperparameters little by little, so it will not impact our accuracy in terms of overfitting or underfitting issues or maximum. Okay, now I want to do another interesting thing. Okay, so what am I doing? Since epochs I'm increasing as a 400, we'll see this time with the batch size 110 itself, with the batch is 10, because that is a pretty good one. Okay, so what do you all think? Now it will increase accuracy, or it will not increase, or it will drop us to some underfitting or overfitting issues? Some of them I think some other different ways, right, based on your experience. Okay, even I myself also not pretty clear, like what kind of values it will be giving. Okay, but if you observe the loss function, if you observe the loss values, it's a pretty good. See, 10, 10, 12, and 23, 20, 17, even 11 also we are achieving. Wow, it's good. Seriously, 9.9. Wow. I hope you are getting a much accuracy this time. Yes, obviously, yeah, accuracy I didn't notice. 95, 96 and all we are getting. So average of all those, maybe we can get 90 plus. We'll see it here. Oh gosh, 89. Maybe I'm trying it evaluate once again. Just apologize me, and I want to check once again. Okay, we'll try it out, whether it is giving any changes on the accuracy or not. We need to understand it, because this is what actually, this is the same way we are working in the real time. Obviously, because developing the scripts and everything is easier for us. Okay, because within 2 days or 3 days we can develop any scripts, and we can ready to be deployed. But when you come for machine learning and the deep learning stuffs, it's always working on hyperparameter tuning is a concept. I mean, it is a matters here. Okay, we have to understand what kind of values you have to change, and you need to concentrate parallelly. You have to concentrate what is that, underfitting, overfitting issues, and it should not drop for any we have to do some dropouts also, because you are not I'm not explaining any dropouts here. So these many factors we have to understand. Now because if my seniors, if my client sees this kind of outputs, in the sense they have asked me the same question, you are achieving the accuracy almost here 99, 96, 98, and the loss function is also pretty good, like 0.0483, because this is all classic bond. But when you are accumulating at that moment, you are getting 18, and how it is possible? So this is a factor we have to work on some mathematical way, and we have to give the explanations. Now yes, now it is good, right? So see the same epochs with the same dense layers, I have deployed this model. Earlier I was getting 89, and this moment it have understand little bit, I guess, but it is giving accuracy. But if you run it next time, obviously this will change. Okay, but you could have this constant, right? So I need to make constant of my accuracy. Yes, that is important. So that is some concept called randomized result. This kind of seed operations is a right. You have to deploy the model with the proper random state, because this is a simple script. That's what I'm not having any random state here. But when you are deploying a real-time model, at that moment you should give a proper random state, because that random state will define the what is that streamed accuracy whenever you are running the model. Because you are running the model, that moment it is giving a 19%. But if you are giving the same model to your client, at that moment they are running, it is giving a 68%. That is really poor, and that will give you the bad impression of our models. So in order to omit it, we have to prepare the random state with the proper values, that will be giving you the proper what is that streamed accuracies. So this is what. Okay, I hope you all bit clear with the script flow, how it actually works, how the model has been works. So now I'm taking the same script. Okay, I'm just going to tweak a little factors in the same script. I'm going to use it as a multi-class classification. So here you have seen only the binary classification, right? 1 0 1 0 1 0, everything you have seen simple factors. But now I'm going to take into the next level to you understand how it will be useful in a multi-class classifications. I'll tell you here. 1 minute. Okay, 1 minute. Okay, so for multi-class classification, I'm just taking iris multi-class classification. Before that, I'm taking the data set. So the same process. Now I'm going to my model, deploy my model here. I'm going to deploy my model here, open notebook in the GitHub, in the GitHub. 1 minute, 1 minute. Yes, one. Here it is, iris multi-class. So multi-class. So I hope you all clear with the multi-class, I guess, because here I have only the two class zeros and ones, and here we're going to handle with multiple classes called 0, 1, 2, 3, 4. Like we have a multiple class we can utilize for that multi-class validations. We can use the same scripts here. Okay, so I'm just connecting my server with the Google Colab, Google server. Yes. Okay. So now, before I explain the script, I'm just telling you the iris data set and what are the data set factors are there, and what are the inputs and what are the outputs, and what are the classes are present up there. Okay, so MLP, same multi-layer perceptron for iris data set. So multi-layers, yeah, I'm going to deploy 1 or 2 hidden layers, or 4 or 5 hidden layers, whatever it is. I'm going to use a multi-layer perceptron for classifying the iris data set. So it is a multi-class, and uh, the data set, it looks like this way. The first one 5.1, 3.5, 1.4, and 0.2. So these and all, each and every branches, each and every columns will be having a different values, like a septon and something else, I forgot actually. Each and every column will be having a different features, and these features are representing whether this flower is related to the iris setosa, and whether this flower is related to the iris versicolor, whether it is related to the iris virginica. So totally we will be having 3 type of classes here. So first class here is Iris setosa. If the flower having this kind of features, it will be represented as a Iris setosa. Okay, I have a multiple data sets for Iris setosa itself. And if you wants to know Iris versicolor, that will be having the values which is related to this. Okay, so I have a set of data sets in order to classify Iris versicolor, and the final class is Iris virginica. Iris virginica, so it will be having this kind of inputs. So overall I have a 150 entries, so obviously it is a very less data set. Obviously it has a very less data entries, so it will not be giving you the perfect output, because at least we should have a 500 or 700 in order to get the proper prediction rate. So with the help of 150, it will not be giving the 100% predictions, but we can, for our trial and error runs executions, we can go for it. Okay, so almost out of 150, 60 or 70 something else will be having each and every classes will be having the data sets. So Iris setosa may have a 40, Iris virginica maybe have a 60, and Iris virginica, sorry, virginica may have another 50. Okay, so this kind of way it will be having a data points up there. Now if you understand by seeing this data set, you can think one. Okay, so earlier the data set output is related to the zeros and ones, but here we have a text. How are we going to understand? How are we going to make our model to understand? Since it is a text, whether our model will understand the text or not. Okay, this is the factors we're going to see. This is a challenges we're going to see in this deployment. Okay, as I told you earlier, so I'm just cloning my repository here. So if you see it here, I'm not having my artificial intelligence, what is that, repository from the GitHub to here. Now I'm just cloning it here. Now you will understand. I'm just running it. So now if you understand here, see, I'm just refreshing my folder. See it here. Okay, it has cloned my repository from my GitHub account to here. Okay, the reason for this, I have a data set. So I have a data set inside this artificial intelligence folder. So I'm just cloning it here. Through that, I'm just importing it here. Okay. Okay. Now I'm getting into the scripts. Okay. Now importing packages. So I'm just importing the necessary packages, NumPy, obviously required, and a read CSV file. So in order to load the data set, I'm using a read CSV and sequential. Obviously, of course, it's required for API. And next one is a dense layer, keras classifier, and NP utils. Yes, required NP utils for some what is the data pre-processing we required, and the cross validation score. Cross validation, since we are using some k-fold concept here. K-fold, this is a k-fold. I'll tell you what uh, a pre-processing technique here, and this will be using for some post-processing techniques, and cross validation and a k-fold. I'll tell you what it is. And the label encoder. So label encoder will be useful to understand, for in order to convert the text to categorical way. Okay, in order to convert the text to numerical way or categorical way, for that purpose we are using a label encoder for data pre-processing techniques and the pipeline. So for the we are doing some pipeline progress, right? For that purpose we are using pipeline. So maximum will not use it here, I guess. Okay, now again the same concept called seed equal to 7 numpy dot random dot seed of seed. Okay, preparing randomness bit selection of inputs. Okay, between the preparing the randomness between a selection of inputs, and the next one is loading and splitting the input and output. So 1 minute. Yes, so now loading and splitting input and output. Now if you see it here, data frame equal to read CSV. I'm just loading my data set and header as an. If you use the numpy, in the sense you have to use a term called delimiters. Okay, here it is not a mandatory, because I'm just directly using the read CSV. So read CSV from pandas, so it's not a mandatory, and header is not nothing, because header are supposed to mention, but it is not there. What is it, septon or something else, a different factors will be, the features name will be there. Okay, that is not there, so that's what I have given. There is no headers, so just none. So you can directly capture the values from the zeroth row and zeroth column itself. Okay, and the data set. I'm taking all the values to the for object called for variable called dataset, data frame dot values. So it will hold all the values to the dataset. Now from the dataset, I'm just splitting input and output as a x and y. Okay, data set of, okay, colon 0 to 4. 0 to 4 in the sense 0, 1, 2, 3, 4. Obviously, fourth will not be preferred, so it will be taking 0 to 3. So these features will be considered as the input. Okay, and in terms of as a float type, okay, so values, everything will be here as a float oriented. So that's whatever it is, the value is related to the float, take as it is. Okay, for that purpose, as float type, I'm just taking as a input values, and a data set, using a data set of colon comma 4, I'm taking a converting as a y values, I mean the output values. So the output values is always iris setosa, setosa, virginica, and as well as virgin color. Okay, now I have splitted input and output as it is present in the data set. I'm not changing a float values into the numerical values or something else. I'm not changing the string values into the numeric values or something else. But in order to you deploy this, in order to deploy a neural network model with the help of these inputs, we have to work some pre-processing techniques. So those pre-processing techniques we could have called as a encoder class values as an integer. So how are we going to pre-process? Label encoder, encoder equal to label encoder. Okay, so with the help of this object, I'm just training the inputs. For label encoder, y is an input. For, okay, for label encoder, in order to convert string to numerical value or string to categorical value, I'm just utilizing this label encoder. So for label encoder, the input value is a output of our model. Okay, data set, I mean, because what is it, iris setosa, iris virginica, iris virgin color is right. So everything is an input for label encoder. I'm just training my model, label encoder model, with the string values of a column of y. Next, I'm just transforming this value. So I'm just transforming these values as a 0, 1, 2. Okay, encoder dot transform of y. Okay, encoder dot transform of y. This encoder underscore y will be having a value called 0, 0, 0, 0, 1, 2, 3. 0 in the sense iris setosa, 1 in the sense iris virginicolor, and 3 in the sense so 2 in the sense, 1 in the sense is in color, 2 in the sense iris virginica. This is a way it will transform that. But if you ask me to use this kind of transformation, I can use. But for better understanding, for better classification, it would be real useful if you are converting all the values into the categorical. So are you confused with the categorical? Before that, I will be showing you, that what kind of transition, because in that you will be understanding a better clear. Okay, so from the beginning, I'm doing just running it locally. I'm running step by step. Okay, locally I'm running a step by step. Okay, so loading and splitting process is done up to here, and just I'm doing the encoding process. Now I'm just printing encoder underscore y. Okay, y. So here I'm deploying the label encoder model. Okay, now see it here. So 0, 0, 0. So these all represents this iris setosa. Okay, this iris setosa. Okay, and now this one, so this is a class 1, 0 is a class 1, and this one is a right, this is a class 2. Okay, this all ones represents iris versicolor. Iris versicolor represented as a class 2. Okay, and the next one 2. So this class 2, okay, this class 2 represents flower called iris virginica. Iris virginica. I hope it's clear up to this. Okay, now you need to understand the difference between a transform and as well as the categorical. Now I have transformed the values between a, as a numerical, between a 0 to 2. Okay, so 0 represents a class 1, 1 represents a class 2, 2 represents a class 3. Likewise, I have prepared my classes. I can directly use this encoded y as my output, so for as output, and I can deploy my neural network model. But it will lead to some confusions, and it will lead to some what is that, non-professionals. So not non-professionals, and it will lead to some confusions. So in order to better understanding, I'm just converting this into the categorical. So if you wants to understand what is a categorical, here I'm printing again. So the reason for printing here, in the sense you will be understanding the flow. Yes. Yeah. See, now 0 1 0. So obviously, so first one 1 0 0. So this represents, now I have converted my classes value into the categorical value. 1 0 0 represents as a iris setosa. Okay, if the value ranges between 0 1 0, so this represents what? Iris virginica, and 001 represents iris virginica. So now I have converted my output values into the categorical values. Now by seeing this representation, you could have understand the output dense layer. Output dense layer, how many neurons we'll use? Obviously we will use 3 neurons. We will use output dense layer as a 3 neurons. If the first neuron gives us a 1 and another 2 neurons represents a value, given as a value as a 0 0, we will consider that as a iris setosa. If the neurons, if the output neurons, okay, first neuron gives a value as a 0, and the second neuron gives a 1, and third neuron gives a 0, so I'll consider that as a virginic color. Okay, so this is what I'm using. This is a this is a process I'm converting for categorical value from the string values. Okay, now my pre-processing is done. Now my pre-processing technique is done. Okay, so now I just what is that, imported the packages. I'm just loaded and splitted input and output. So obviously my output is a string type of classifications. That string type of classification will not be the result good. So in order to work on it, in order to work on it, it would be very clear, it would be very good if my what is that, if my what is that, y values, I mean the string values, converted into the categorical value, that would be pretty clear. So that is why I'm using label encoder to convert string value into the, what is that, categorical value. So the next, directly getting into the model. So before that, okay, before I'm explaining this particular segment, I'm just going for the k-fold validation. Okay, now estimator equal to keras classifier. Okay, build function equal to baseline model, and the epochs is 100, and batch size is a 25. Okay, so now whenever it represents a baseline model, whenever this particular line executes, at that moment it refers a method called baseline model. So if you go for the baseline model, okay, I have a normal API called sequential API. Okay, in that sequential API, I'm deploying a hidden layers and the input layers as a these factors. So first input layer is a 4 dimensions. So because I have a 4 type of inputs here, features, 4 type of features. Just a minute, 4 type of features are here. For that I'm using input dimension as a 4. Okay, so dense layer is a first hidden layer with the hidden neurons as a 12, and the second hidden neurons, and second hidden layer with the hidden neurons called 6, and final output layer, as I told you earlier, output neurons as a 3. Okay, and now I deployed my model into the sequential API, and I need to compile it. Okay, I need to compile it with the loss function called categorical cross entropy. Categorical cross entropy is nothing but, earlier we have used binary cross entropy, right? Since it was a, what is that, a binary classification. Here we are working on some multi-class classification, so we required some categorical cross entropy, so categorical related classification. So for that purpose, I'm using a categorical cross entropy as a loss function, and optimize the same, I'm referring Adam, and then the matrices, obviously here I also consider some accuracy. Okay, now with the help of this model, okay, now it will return this model. Now you have the some question. Okay, now you have some questions in your mind. So why we have to use keras classifier here? Okay, why we have to use a k-fold classifier, is a k-fold validation here? Okay, so it's not a mandatory to use keras classifier as an estimator. It is not a mandatory, you have to use a k-fold validation. For better classification, for better validation, we can go for this kind of things, this kind of what is that, progress. First in is a keras classifier I'm using, same operation which we have done in a model, which we have done in a, what is that, binary classification. The same operation we are doing here, but with the help of keras classifier. But the baseline model, this model, the same compiled model, and here I'm just giving the epochs as a 100 and batches as a 25. Okay, now I'm stored as a object. Okay, now my Keras classifier is stored as an object with the actual model with the epoch of 100 with the batches of 25. Okay, now I'm creating another object for the k-fold validation. Here I have given n splits as a 10. So k-fold validation, before directly getting into it, oh my god, k-fold, have lost the picture, I guess. Okay, just give me a minute and I'll show you k-fold, k-fold validation. So if you see this picture, you will be understanding a better way. Better images, yes, here I have. Okay, so now if you see this picture, okay, now overall images, okay, overall training data is there. Okay, I have 100 data points as training data points. Okay, overall I have a training data image data points as 100 data points. Now what am I doing? Generally what we'll do, we have a set of training data set and we'll be having a set of testing data set. From the overall data set we'll be splitting this one. So with the help of a k-fold, I'm using the complete data set as a tested data set using the folding methods, so first one, okay, now test data and training data, overall is a training data. First I'm saying, first take 5 images as a test data from the training data set, so remaining images as a training images. Okay, first iteration, during the first iteration. So the second iteration, okay, second iteration, what it is doing in the sense, it is taking a next 5 images as a testing data and remaining images as a training data sets. Okay, during the third iteration, okay, so from the last taking the from the last taking the next 5 set of testing images and remaining will be the training set. So by doing this kind of k-fold validation, users is, because rather than choosing only the 10 to 15 images as a testing images, we can use the same data set which is present, we can use the same data set which is deployed with the what is that compiled model, in order to understand how precise our model is and how my model is understands the complete data sets. Because it in this kind of validation will give the clarifications, will give the clarifications as like what is that, it is not memorizing. Okay, if you're doing this kind of careful validation, your model will not memorize the complete training data set. Okay, for that purpose we are using this kind of careful, but this is a process we actually do. Okay, we'll be having a overall training data sets. Okay, from the overall training data sets, first 5 images I'll be taking as a test images, remaining will be as a training data set. So next 5 will be taken as a test data set and the remaining things will be as a training data set. So likewise it will be going for the how many folds you are giving. Okay, how many, so here I have given a 10 folds. Here I have given an n splits as a 10 split, so that means 10 fold during the one iteration. Okay, during the one iteration 10 folds, that means 100 data set in the sense, what is that, 10 to 100 data set in the sense 10 images will be considered as a tested data sets. So likewise I'm doing the k fold validation with the with the fold value of 10. Okay, so the randomness here I prepared as a seed. Okay, that seed 7 I have given, right? So randomness will be happened here, so that my data points will not be in what is that, same format of a 1 2 3 4 5. It will be clumsiness. From the clumsiness it will pick the 10 folds. Okay, I have created an object for the k fold. Next I'm creating the cross validation, so I need to validate the cross validation score. Okay, so how are we going to validate this cross validation? So here the concept comes. Okay, here the concept comes, we are using the model, Keras classifier model, with the help of baseline model with the epochs of 100 and a batches of 25. Okay, and so far we are not trained, or we are not trained with the input and output images. So here we are giving the input and output images with the cross validation technique called k-fold. I hope it's a bit confused, I guess, right? Okay, it's a simple, very simple. So far we have done, because why am I explaining this kind of format in the sense, different type of, because this is a very simple data pre-processing technique we have approached, and this is a simple k-fold validation we are doing. So whenever you are seeing this kind of scripts, you could have think in a next order when you deploy your own scripts for that purpose, because some places k-fold validation may not required. Okay, obviously this kind of multi class classification, especially for this kind of 150 entries present, what is the data point data sets, obviously k-fold is not required. Okay, so but for better understanding, I'm taking the concepts into here to one to be explained. Okay, so the estimator equal to Keras classifier. So baseline model I have used with the epochs of 100, batches of 25. So this object I have given, using this object I have given a, what is that, input and output as x y, and the cross validation technique called k-fold. Okay, now I have get a results here. Now I have got a results here. I will show you its mean and the standard deviation. So here standard deviation outputs not required, only the mean outputs we can look into it. Okay, and another, got it. Yes, so here I'm executing the output. Let's see. Whether it links queue. Now again, incomplete format, missing some semicolon or somewhere else. Okay, just come for the older strict. Okay, I'm just executing it again. Some nan, so nan in the sense, some missing values cause of invalid arguments. Okay, again the init so concepts. Okay, the errors updated due to that this issues occurred. Oh my god. Okay, here I removed inits again, because initialization by default will be considered as a normal henceforth in a keras. Again I'm deploying my model without init. So this time, yes, processing is happening. Okay, so now, so accuracy is a very poor, because the data set is a very less, 32%. Even whatever you does, for example, whatever in the sense, if I increased input neurons, so output to neuron 64 and the 32, I think it will not give the good output, since it has a less number of data sets as a 150, because hmm, it's much better. Okay, so 42%. So however it will not reach, what is that, if I increase the dense layer as a 128 or 128 and 64, and if I increase the dense layer for another two layer hidden layers instance, it will be go for underfitting issues. It will go for some, what is that, overfitting issues, because it will completely memorize your model. It will completely memorize your training data, obviously, because the data sets are very less. Okay, obviously your model is confused with how to classify and with the factor of which values to be classified. Okay, now if you increase the dense layers, and if you increase the dense neurons more in the sense, obviously it will start to memorize the things which you have given. It will start to memorize the data set we have given. Obviously it will lead to some overfitting issue. Maybe this output also might be okay, giving some cause for overfitting issues. Sometimes it is possible. So that is what we have to be very careful whenever we are tuning the hyperparameters, whenever we are using a k-fold validation. K-fold validation is the best validation technique. This kind of cross validation technique is the best technique. Whenever, if you have 1,000 and 10,000 images, at that moment k-fold validation is the best solution, but it will take a bit more time, but it is the best solution. And more than that, your data set should have a valid information. It should not have repeated values, and it should not have some, what is a junk values or something else. It should have some proper values. In order to do it, you have to do the lot of data pre-processing techniques, because missing values you have to reduce, and similar values you have to reduce, and what is that, replica values you have to reduce. This kind of data pre-processing techniques you should approach before you deploy, what is that, k-fold validation, or before deploy neural network models. Okay, and I hope I have done my part with this too. And I thought of taking some real-time examples using the home sales prediction, but almost we are running out of our time, I guess. It's 11, right? Yes. So any doubts so far up to this in the script? Any doubts? Okay. So then, So if you have any doubts, and I will be giving my mail ID and as well as my contact number here. So Ganesh 92 92j at gmail.com, and it's my contact number. You can give me a WhatsApp at any time. And oh my gosh, sorry. So this is my contact number and this is my mail ID. If you have any queries which is related to neural networks or deep learning, and if you have any doubt which is related to the data scientist also, you can drop me a queries and I can give you the solutions to it. And if you have any informatives, or if you want that, so and if you want this kind of scores, sorry, if you want programs, in the sense, you just go to my GitHub account Jayish19, and you can get all kind of scripts up there, because everything is updated one. And still I'm working for some GAN and generative adversarial networks, and as well as some what is that, natural linguistic programs. Everything is being processed, and very sooner I will be posting in this GitHub account. And in very future, in near future, I'll be creating some YouTube tutorials, and everything will be in the, all the links and everything will be posted up in this GitHub account itself. Please get in touch with the GitHub account. And if you have any doubt, as I told you earlier, you just drop your queries um, to my mail ID. And if you want any queries or services in the future, you just contact me over this contact number. And I hope I've done my part well. And since it is a coding part, so it's always will take some time to explain it out. And obviously, thank you so much. Excellent. Thank you so much, sir. Thank you so much, everyone. So I'll
Jai Ganesha, thank you so much for your informative sessions. Participant, any queries? Sir, actually, from the participant side, they have given a very good command. So,
yes, sir.
really, we appreciate, sir.
Yeah, thank you, ma'am. Thank you so much. Thank you so much for everyone,
Really,
sirs and madams, who hold this session for me and bear
actually,
with me.
it's a
Yes,
very practical session. So, I think all the participants are much clear in this particular topic, sir.
yes, yes, yes. Thank you, ma'am. Thank you so much.
Thank you so much, sir.
Thank you, ma'am. Thank you so much.
Sir,
Once again.
some of the participants have asked the PPTs. Definitely, ma'am, we will share
Sure.
that PPT in your Gmail account. Now thank you so much, Jai Ganesh sir. Once
Thank you, ma'am.
again, now the participant, we will have a break for 10 minutes. At 11:20, we can rejoin it again for the next session.
Yes. So thank you so much for every sirs and madam here and hanged up here. Thank you so much. I'm just signing off now. Thank you so much.
Thank you, sir.
Thank
Thank you,
you.
sir. இப்போ நம்ம லீவ் கொடுத்தோம்னா எப்படா டேய் எப்படா ஸ்டாப் கொடுக்குறீங்க கன்வெர்ட் ஆகணும்ல லீவ் கொடுத்தாதான் கன்வெர்ட் ஆகுமா ஸ்டாப் கொடுத்துட்டேன் லீவ் கொடுத்தாதான் வரும்டா ஆமா லீவ்